Welcome, GeoTrig. This is section 4.5, Isosceles and Equilateral Triangles. The essential question is, what are some special relationships of isosceles and equilateral triangles? Let's begin. So what is an isosceles triangle? Well, if you don't remember, the official definition is a triangle with at least two equal sides. So at least, so it could have three and it's still isosceles. In this case, these two sides are labeled B length, so they're equal sides. So that's an isosceles triangle. Well, what are some of the key parts of an isosceles triangle? We have our legs, which are the two congruent sides. So in this case, the two left and right legs. The base is the third side. So it's a side that's just not necessarily equal to the other two. The vertex angle is the angle that's formed by the legs right up here at the top. And the base angles are the two angles that are connected to the base. So down here and down here. All right. So one theorem for the isosceles triangle. This is where we're actually using this. If we have two sides of the triangle congruent, so basically if we have an isosceles triangle, then the angles opposite of those sides are also congruent. So if these two sides are congruent right here, CA and CB, then angle A and angle B are also congruent. And we can prove this. So right here I have an example of an isosceles triangle. It's triangle XYZ, because these two sides are congruent. Well, what you can do to prove this is I created a bisector here, and this created two separate congruent triangles. So here's how this works. So let's call XB is going to be my bisector. It's going to bisect the angle, let's see, we're going to bisect angle YXZ. So that bisects that angle. Then we can say that angle YXB, so YXB, is congruent with angle ZXB. So this angle right here and this angle are congruent. So basically angle 1 is congruent to angle 2. Well, we can also say this side right here, XB, that's formed from the bisector, it's matching on both triangles, so we can say XB is congruent with BX, sure. And because I have a side that's congruent and an angle that's congruent and a side, we can say that those two triangles, triangle YXB, is congruent with triangle, let's see, ZXB. And we can say that because of side angle side, going back to the last week's stuff. And because those triangles are the same, we can say that angle Y is congruent with angle Z because they're corresponding angles of congruent shapes. So corresponding angles are congruent. So that's when we can prove it. Now, the converse of that theorem also works. So if we have angle A and angle B, the two base angles right here, then we can say that sides AC and BC are also congruent. Another theorem with isosceles triangles. So if you have a bisect, you have a line that bisects from the vertex of an isosceles triangle, that line is going to be perpendicular to the bisector of the base. So basically, this line right here and this D is going to form two right angles. And that's going to be perpendicular, and it's also going to bisect this base. So this segment AD right here is congruent to segment BD. And we can use this information for proving other theorems. So a good thing to know. Alright, so a corollary. So what's a corollary? This is a theorem that we're going to prove using another theorem. So it's kind of an extension in a way. So we can use corollaries in proofs. So one corollary of the isosceles triangle theorems is if a triangle is equilateral, then if a triangle is equilateral, then the triangle is equiangular. So equilateral triangles, what are those? They have three sides equal. In this case, we have three sides equal in an equilateral triangle. But because of what we said with isosceles triangles, we can also say that all three angles are also equal. And you might know that anyways, because equilateral triangles, every angle is going to be 60 degrees. I mean, you probably know that. But it's nice to see that in a proof. And we can prove that because we know that with isosceles, these two angles, these two sides, XY and YZ, are going to be congruent. That means the two base angles ought to be congruent. And if you rotated this and said, well, if these two sides are congruent, then Y and Z have to be congruent. And then that means everything has to be congruent. And so we can also say the corollary of the converse as well. So, I mean, this is all congruent equilateral triangles. Let's do some examples. So pause the video. Alright, let's begin. What are the measures of angle A, angle B, and angle ADC? So I'm looking at this shape here, and I see a bunch of 1 tick marks on these sides. Looks like I have a bunch of equilateral triangles here. So that makes it kind of easy. This is angle A right here. So angle A, we can say the side of every equilateral triangle has to be 60. So the measure of angle A is 60. And the measure of angle B, well, angle B is right here. It's still equilateral triangle right here, so that's also 60. Let's look at the measure of angle ADC. So ADC is this big one right here. So it looks like it has two of these angles together. So I'd say the measure of that is going to be 120, and that's it. All right, next one. Pause the video. All right, let's begin. Is segment AB congruent to segment CB? Explain that. So basically, is this one congruent with this one? Okay, so we got to figure this out. Let's see. Well, one thing we know, if we got two triangles going on here. Notice we got this angle right here, angle A, and we got angle C, and they both have one arc. So if they both have one arc, we can go back to one of our theorems, the converse, way up here. If we have two congruent angles, then this is an isosceles triangle, and these sides are congruent. So going back to this, because is this AB congruent to BC? We say yes. Why? Because angle A is congruent to angle C, so then AB has to be congruent to CB because of the theorem. All right, next one is angle A congruent to DEA. So what's DEA? Let's see, clearing my work a little bit. So angle A congruent to DEA. So is that congruent to this one? Yes, it's going to be. Why? Because we have two congruent sides right here for AD and DE. So I'll call this DA is congruent with DE. So we can say that angle A has to be congruent with angle AED or DEA because it's an isosceles triangle. Next one, pause the video. All right, what's the value of x? Okay, so x is this angle up here, and this angle is 54. Well, okay, so to get x, we need to have all three angles here. We need to judge because three angles of the triangle add to 180. So I got x, and I don't know what this is, and I don't know what this is. But I do know that of this big triangle, we have triangle ABC. We can say that is isosceles. Isosceles. Why? Because AB is congruent with line BC. So side AB is congruent with side BC. Those are two legs of the isosceles triangle. So because we said this is one big isosceles triangle, then we can say that angle A has to be congruent with angle C. So that means the measure of angle A, so that's 54. Measure of angle C also has to be 54. So cool. So we know that's 54. But what's this angle right here? We can go back to the bisector theorem. So BD is a bisector. So BD bisects that angle ABC, because it's bisecting an isosceles triangle. Since these angles are congruent here, therefore this forms a 90-degree angle. So I know that's 90, and this is 54. I can create an equation: x plus 90 plus 54 has to add up to 180. It's doing the math there. I get x plus 144 equals 180. So x has to equal 36. That's it.